So we working with the free textbook. I know that some people just recently added this class and may have difficulty figuring out what this means to have a free textbook. Well, all you need is to go Google search and type the name of class, intermediate algebra, and then the name of the author, Gustafson. And we're using 10th edition PDF. That's the key word here, PDF, the one at the end, because that way you will get a free textbook. Otherwise, there'll be all kinds of advertisements. So now I click on that PDF and I get the book here for us. So that book is what we will be using throughout semester. It's a nice textbook and it's also free. So I guess we got lucky that we have a book that also has answers at the end of every exercise. So you know how to actually work the problems out. So we'll go to first section of chapter 2, where the working on chapter 2, we were graphing some equations, line equations. So I'm gonna need page 91. So I'm gonna add about 30, so it'll be like 121 and get to the chapter. So the quick way to access your page is to add about 30 to the page in the contents. And that's how I jumped into section 2.1 that was talking about making point plots and then connecting these points with a straight line. So we need 2 points for that matter. So let me go to the section end where the exercises were and see how we graph those problems. So I'm going to do one exercise just to refresh your memories on how we used to graph these. And let's say if I try exercise number, probably did 49, so we go the lower, like number 51. I think that's the one that does not look very familiar. So it turns out all problems are pretty much the same, but one still needs to do a couple of them to make sure that you feel comfortable with these. So problems like 51 that has 6x minus 3 times y is equal to number 12 should be graphed using a pair of different points, and these points should be, well, just about any numbers you like. But when I'm looking at this equation, I notice that zeros will be very convenient numbers to use. Why is that? Well, let's say if I replace letter x with a 0, then the first term will completely disappear right away. So that 6 times 0, so instead of x I put 0, will go away, and then I see that my letter y should be 4. 3 times 4 is 12, but it is negative 4. So I think it's a faster way to get the answer and the simpler way. So if you go simpler way, then you don't make a mistake. So that's why I recommend using zeros if both x and y are on the same side of your equation, just like we see it here. So when I replace y with a 0, so now I want to find the other point here because I already have first point on this graph, pair 0 and negative 4. So I will now need to use a 0 for letter y to get another intersection with axis. And I see that 3 times 0 goes away, so we get a x, which is 2, because 6 times 2 is 12, and this is my second point. So looks like we got 2 different points that I can plot. One of them on y-axis, so that'd be -4, and the other one will be x equals to 2. Yeah, you don't have to come to school at all if you especially stuck in traffic or something. So no worries. I'm not gonna punish you for that. And we could just stay at your place without any traffic and see all that with the, I guess, your own device. Or you can check the recording, because I'm recording this lecture. So even if you cannot make it, no worries. You email in a few hours recording of this lecture, so you will see what we did in class. So I guess that makes things convenient. And looks like now what I do is, after 2 points of intersection with x-axis, which is 2, and with y-axis, which is -4, were produced, I plot them and connect, so we got a graph of this line. So that's, I guess, the way to go with all exercises that ask you to graph lines. Well, I guess we'll move on and we'll see there are some more lines appear in the next sections. So section 2 of this chapter continues dealing with lines. We already know that 2 points determine those lines, just like we did in the previous exercise. So if you have point with coordinates x and y, and another different point with coordinates x and y, but we like to distinguish those points. So first I call it x1, y1, and the second is a pair x2, y2. Then these could be connected to give us a unique line. And turns out that I can describe this line by using so-called slope. I don't know if you ever heard that word, slope of line, which is a fraction that says y2 subtract y1 in numerator is divided by x2 subtract x1 in numerator. You say, Alex, what is this? Well, this is a slope of line that, if you never saw this before, then, well, you probably should get used to this a little bit. And they make a nice explanation of what is going on here on the page 107 that you can quickly access to if you type 139 in that PDF file. So it turns out that slope of line, which is here, is treated sometimes as so-called rise divided by the run, and the rise divided by the run. So, oh, you can't come to the class, and no worries, I record lectures. In fact, I told students that you don't have to come here at all, because I was planning to run this in a Zoom format, this class. So if you cannot be at school, that's fine, because that's not a face-to-face class anyways. I'm coming to school every once in a while just to make sure that students feel comfortable, but may just not come at all. In fact, today I probably should have stayed in my place. I have a little bit of sore throat, so it's not very much fun. But anyways, main reason why I decided to come to campus, because I saw some people added a little bit later and they needed my help to find a textbook and, I guess, to figure out what's in the syllabus. But I guess starting in a couple of weeks, I'll when we get closer to the midterm exam that I plan to give you an online format, I will just be online, because if you give tests in online format, then it should just be consistent with online class. And if you do it face-to-face, then you should give face-to-face tests. And I know that students usually prefer online tests. So I will just email you the set of questions, and I will wait for you to email me your work back. And this way, you're not going to have just 50 minutes for this from 7 to 7:50 in the morning. Some people might have issues, I know, with our traffic or other things. So I will just email you this midterm exam, and we'll wait till the afternoon time. So this way you will get plenty of time to complete it, make pictures, and send it to me by email. So we will talk about this when we get closer to the middle of semester, to the midterm in the middle of February, because I guess midterm is going to be sometime in week 3 of February. So this way we're going to run the class in this online format only, but again, starting in a few weeks, because looks like some students might need a little bit more guidance on my side. And that's why I first just come in here, because I'm on campus anyways, but just make sure that you get the best possible grade. In fact, you probably already checked the Blackboard and saw that I start everyone with a perfect, with A grade, and that way it's much easier for you to, first of all, know what you're getting on class, and also to keep up with this grade. So if I see someone keeps on missing quizzes and does not take a midterm, well, the grade will definitely not going to be an A, so it'll go lower. But if you see the grade goes lower, I can always help you to bring it back up higher. I think that way is more convenient, and it actually gives students better results on class. And I guess grade is what people care the most, right? So, and that's why I guess I'm fine if you get perfect grades. In fact, that makes me also happy. So please don't worry. If you cannot make it to class or a little late, that's fine. Just check the recordings of lectures so you know what you missed. So anyways, we started to talk about section 2.2 that deals with slope of the line. So I will try to see what this really means for some kind of line to have a slope. And I guess they have a very nice picture here, and that's why I wanted to use their work to show how we can determine the slope of line that connects these 2 points. So notice they just utilized the formula that we have for the slope. So they replaced in that formula y coordinates, and those were negative number 4 and positive number 4. So we subtract this y coordinates, and then we also replaced in that formula x coordinates. So once I did that, there came out to be some negative number for slope. And we can visualize why this is negative from the picture. People say this is so-called falling line. So if line goes down, then slope is negative. If you trace it from left to right, so if you keep moving along the line left to right, the line keeps going down. And also you can see so-called run and rise. Actually, for this particular line, we don't have a rise, but it's a fall because the line is actually falling. It's actually pointing downwards. So we saw that distance along this y-axis, we go down by, they say, -8. And then the rise the run with 5. So 5 for the run, that's my denominator, and -8 for the rise. And that's how we get that negative slope. So whenever we're discussing line, word slope is always around. And that's why I guess we should feel comfortable finding the slope. So I will go to the end of the section and try to do a couple of problems that say, Alex, find slope. So if you remember at the end of the section, you don't want to worry for homework such groups of problems as warm-ups or review exercises or vocabulary problems. So these are ones that you can disregard. But what you really need to look at will be problems called practice. So practice exercises in this section presented not with too many. You can see just a portion of page, because on the next page we already have applications, and that's something that I told that you should not worry about, or additional practice, some extra practice. So that's something that I will not really care for. But the standard problems that deal with slope of the line, so like problem number 25, is something that's worth to do. So let me try exercise 25 that says pair -2 and a +5. That's the first point. The next point, the next pair is 7 and -3. So that's another point here. And now I can find a slope for the line that will connect these points. Notice that I don't have to graph any lines here. They asked me, Alex, give us a slope. Okay, so I will prepare these points and give them this slope, M. That's what we'll always use for slope. And there'll be two differences that I need to consider. In numerator, I subtract y's, such as 3 and 5, y coordinates. And in denominator, I'll subtract x coordinates, such as 7 and -2. And then after we simplify these, we'll see what the slope is equal to. So that be -2 in the numerator. And looks like with the two minuses, I'm going to have a plus sign. So it's going to be 9, right? So my slope is -2 9ths. Usually people pull the minus sign out and we just have 2/9 and negative in front. So that's our actual result. So to find slope, I always use that little formula. Turns out that for exercise like 31, we don't really have to worry about such a formula at all. Let me try exercise number 31 that says 5x plus 3y is equal to 15. So in this exercise, I can actually do a little bit of a shortcut in finding slope. What I can do is isolate a known letter y. So I'm gonna bring that 5x over to the other side, subtract it. So it's gonna be -5x, and there'll still be plus 15 at the end. And then we'll divide on both sides of my equation by number 3, just like that. So you say, why would you do that? Well, because it turns out that now, once I see what y is equal to, I can find the slope of my line a little bit differently. So it turns out that the number that I have multiplied by x is going to be nothing else but the slope of that line. And that's a pretty neat way to find the slope that actually next section of this chapter 2 is talking about. They decided to separate the story of line material into various little sections, but it's actually one big story that says lines are given with a slope equation, such as a slope m multiplied by letter x plus a special point, so-called y-axis intercept. And this way you can not just find the slope, but also graph these lines. So let me show you what this is all about by going back to this same exact equation and try to actually graph it. So if I take this again, 3x plus, actually it's 5x, should be careful. I need to wake up, I guess. 5x here plus 3 times x and equals to 3 times y is equal to 15. So we just graphed equations by using intersections with x and y axis, right? That's what we did when we started the class. So I use a 0 instead of x. So this first piece of equation right away turns into zeros. 5 times 0 is 0. So when I solve 3x is equal to 15, I see that 3y is 15. I see that y should be 5, because this way I find the intercept, right, with my axis. That's what we already did today. So I try another 0, but now instead of y. And when I replace in this equation letter y with a 0, I'm going to have to put this 5x plus 0. 3 times 0 is 0, is equal to number 15, and 5 times 3 is 15. So I got myself another point. So if I graph this line, if I plot pair of points 5 on the y-axis like that, right, and 3 on my x-axis, some place here, then connect and get a line. When I connect these 2 points with each other, I get a line. I hope I get a straight line, so you can connect them carefully. And please notice about this line, there is one interesting fact. The intersection of this line with y-axis is right here. It's number 5. So this is so-called y-axis intercept. And that's why this equation is so popular, this form of equation with y on one side and everything else on the other side. So you can see that intersection point with y-axis. And also you can see what the slope is. When you say, Alex, how do I see what the slope is? Well, remember, if we move from one point to the other horizontally and then vertically down, so we say that run, which is a change in horizontal positions, and a rise, which is change in vertical positions. They will be number 3 here, right? Because that's 3 units from 0 to 3. And the rise is 5, but with a negative sign. So if I want to divide the rise over run, remember to get slope, I will divide -5 by +3 and get exactly what was produced in the exercise 31 right after I started it. So the point of story is all this work could be done much faster if you simply isolated y. So that's what the next section tells us. And I guess that's very exciting to know that this is the way to go. So we could just move to section 2.3 and indeed get this checked out with the equation in the form mx plus b. So let me go here to see this. So writing equations of lines. Where is it? Here's the set of exercises. So let me try to practice to get some of these exercises done. So let me try exercise number 39 here, for example, or maybe I'll start with, yeah, let's do 39 and then I'll do 35. So let me do a couple of problems in this section to start and to enjoy. So let me clear this a little bit. So slope and intercept form of equation of a line is here. So let me go for number 39 that says in the section 2.3, write this in a slope intercept form, which means write this in the form above that so-called slope and y-axis intercept. So if they gave us y plus 1 is equal to x, it means that I need to isolate letter y or to subtract number 1 on both sides of this equation. So we could do it right away. So just bring that 1 over to the right? Subtract 1 on both sides. So I can identify what the slope is. The number multiplied by x will be slope. And since this is just 1x, then the slope is equal to number 1, right? And also intersection point with y-axis. So that'd be y-axis intercept. And that's another piece of information they want. So you can see the answer next to the exercise right away, and that's great. So you can verify that you did it right. And that makes lots of people very happy when you do it right. It's good, right? So you put a -1 on the y-axis, that's your intersection with y-axis. And then use the fact that slope is equal to 1. So looks like they're trying to graph the line down below. In fact, that's what they ask here in the exercise, graph this line. So they use the fact that slope was equal to 1. So if slope is 1, and that's rise divided by run, then I need to identify what is my rise and what is my run. And when you say, Alex, rise over run is a fraction, but number 1 is not. Well, I can make it be a fraction. I can divide it by 1. So any number you can divide by 1, nothing is going to change, but you're going to see what is your rise and what is your run. They're both the same. They're both equal to 1. And this is just great. So I'm going to run by 1 and rise also by 1. Why I do this? I need another point. Remember, to graph the line, we need to have 2 points. So you have one, which is intersection with your y-axis, and the other point is here. So when I connect, I get line. And this is good, and that feels right. And I guess that's just the way to go. So here we have produced equation of line in a slope intercept form. So let's do it again. I guess this slope intercept form is so popular that I can try one more exercise here to get number 35. I think that was another good choice. Notice in exercise 35, they just say find slope and intercept. They don't talk about graphing, so that's a little less work. Okay, so let me isolate letter y, right? So if I have 5x, be careful, put 5 here. 5x and added with 2y's is equal to 10. So try to find the number multiplied by x, which is going to be your slope. But not so fast, because first of all, you need to bring that 5x over to the other side, because we need to have only letter y on the right. So I'm going to subtract 5x and then divide by 2 every term in my equation. So we got y, which is equal to negative 5/2 times x and plus 5. And this will tell us right away what the slope is and what y-axis intercept is. So here I have slope, which is negative 5/2. That's start, right? And y-axis intercept, which is number 5. So once you isolated letter y, that's it. You're pretty much done with this process. So I guess today's goal is to deal with equations of lines. And the key idea is having the slope and y-axis intercept present. And I don't think I'm going to give you a quiz. Maybe I'll say a couple of more words about equation of line instead, because I think it's very interesting and exciting story. In fact, this is all based on the slope. And it turns out that what you can do is rewrite your slope formula a little bit differently. In other words, you can clear denominator. So if I have the slope formula that, let me recall what it was. Get this room here. Remember, we had x1, y1, x2, y2. So these coordinates of points. So slope was a fraction, y2 minus y1. Today is a formula day, so I guess I don't want to give you a quiz. It may be a little bit too much. Just look at this slope formula and notice that what I just produced here on the right has no denominator. But this x minus x1, that denominator that I used to have before, is now brought over to the other side of equation as if you multiply it by it. And that's exactly the case. So it turns out that the slope formula could be treated a little bit differently. And then, well, it turns out that we have equation of line here produced that goes through that point with coordinates xy, or actually x1 and y1, and it has a slope, as usual, called letter M. So line with a slope that passes through the point has this particular equation. So let me do one exercise here, like problem number 19, to show that whenever you have formula, all needed is to replace letters with numbers in that particular formula. So they tell slope is 1/2 and the point is square 1, 5. So point will always treat us square x1, y1. And here's our slope. And I'm gonna replace these three numbers into equation above. And this will give us the line that we supposed to find. So when I replace my y1 with a number 5, so I subtract 5 because y1 is 5, then instead of slope I put 1/2 here, and finally x1, which is number 1. I produce the equation of line. This line passes through point they gave us, point coordinates 1 and 5, and it has slope 1/2. So we have this equation to simplify a little bit. Remember, we always want to write it as mx plus b. So I want to distribute that 1/2. So put a half times x minus 1/2. And also bring that 5 over to the right side. So I get a plus 5. Because we always want to isolate our letter y. So we get a 1/2 times x. And then 5 minus 1/2 will be 4.5, or some people say 4.5. You can put this in your calculators and get the result. So I guess this section has quite a few formulas. It has slope formula, it has equation of line formula, and this mx plus b, which I hope you're already a little bit familiar with. So I think that next time I should go over these formulas again, so you will feel more comfortable, I hope. And then I'll give you a little quiz on this, because I think it might be a little bit too much if I start quizzing you on this formula stuff. You want to probably see it a little bit more, and maybe over common weekend to try to at least to redo those problems that I did today in class. And I guess that'd be good enough for now, so you don't get overwhelmed. I know today is Wednesday, and some of you even made it on campus, and that's tiring, of course. So you can always stay in your place if you want to sleep. I'm sure sleeping on this thing is like a yoga. It's very hard. You put nails, and it's just like torture. Get yourself a nice pillow. I actually had a student in one of my classes that used to bring a pillow and say, Alex, I hear tone of your voice, and right away I passing out. I just can't handle this. So just don't give yourself such a hard time. Stay in your place and nice, conveniently enjoy and relax. And I'm sure that sometime in the afternoon, when you already feel recharged, you can always do some work more productive. And that's the message. So just to relax, and when you need to relax. And I guess that's why I let my students to basically do whatever they want. I think you deserve some level of freedom, right? Why should I try to discipline anyone? It's probably not fair, right? And that's why it's fine with me if you take a break or rest or whatever, especially when we're going to have a test in this class, when we're going to have a midterm, which I usually produce with some exercises. So sometimes people do one problem and get so tired, say, Alex, no, I need a break. So just I need to like have a nap for 10 minutes and then wake up and do another problem. And that way you get better results. And please understand that I'm serious. I'm trying to make sure that I test how you do math, not how you organized or how you're coming here or some other things. It's not math. Math is you sit down and you solve problems. You can do it. That's fine with me. And that's the point of all of this story. And of course, if you happen to miss some stuff, I record lectures, but those recordings don't stay forever. they disappear. So 30 days, college keeps the recording, and then, well, since they didn't pay for a longer time, the Zoom simply erases those. Well, but I'm sure there's a reason. It costs tons of money. There are so many campuses, right? And so many instructors record their lectures. So I guess that's important to realize. Even though I do send you links to lecture recordings, you really want to watch them within the hopefully same week or over weekend. So don't postpone it for next month because they just might be gone. So you won't see them again. You click on and say, Alex, there's no recording. Well, yes, it's 30 days. If you wait longer, then it's not going to be available. So that's something to realize. But I think it is convenient that you do have recordings of lectures. Let me stop recording all that.